I will talk about STEAM and educational robotics for inclusive education. I am educational consultant and a postdoctoral researcher at the University of West Macedonia in STEM fields. So I will start with a little bit talk about the introduction of STEAM. The introduction of STEAM in education started from the need for student literacy in STEM fields of knowledge in such a way that they choose careers related to these disciplines. At the same time, the need of society to have equal access of all to the development of skills, but also in the professions related to STEM fields, makes necessary STEM introduction to formal education. So, what are these four disciplines? Are science, technology, engineering, and mathematics. Science enables us to develop our interest and understanding of the living, material, and physical world, and develop the skills of collaboration, research, critical inquiry, and experimentation. Technology covers a range of fields which involve the application of knowledge, skills, and computational thinking to extend human capabilities and to help satisfy human needs and wants operating at the interface of science and society. Engineering is about the design and creation of products and processes drawing on scientific methods to provide the skills and knowledge to solve real-world problems. And finally, mathematics equips us with the skills needed to interpret and analyze information, simplify and solve problems, assess risk, make informed decisions, and further understand the world around us through modeling both abstract and concrete problems. So, STEM methodology contributes an interdisciplinary approach to education that breaks down traditional barriers between subjects and disciplines in order to link STEM to digital technology education. STEAM activities to the arts with the arts, humanities, and social sciences. And in one hand, to address critical shortages in skills, and on the other hand, encourages the development of transversal skills which promote innovation and creativity. So there is a number of pedagogical approaches can be used to integrate STEM into the curriculum. First of all, focusing on truly affecting problems, offering students opportunities to make connection between subjects and to develop problem-solving, diagnostic and critical thinking skills, including research, hypothesis testing, analysis, synthesis, and strong abstract reasoning for achieving solutions to real problems. For example, how can we prevent waste in our school community? Setting a design activity at the beginning or end of a task so that students can apply this STEM knowledge. For example, the construction of a catapult, which is an activity with excellent motor skills, engineering, practicing maths, and creativity. Problem-based learning with the choice of open-ended problems and the available support in guiding the learning process and informing at the end of a learning experience. For example, how can we find solution or how to sustain this little cup and make it stumble? Challenge-based learning with a final product, although this product is defined, has a focus on the use of IST and the framework that consists of 3 interconnected stages: engage, investigate, and act. Project inquiry-based learning, which is similar to problem-based learning, is organized around a common goal. But the role here of educator is much more stronger. For example, a research or on germination. And thinking-based learning, and of course design thinking. Design thinking is offering a thinking scheme capable of generating solutions with 5 different stages. The first phase consists of understanding the problem. The second phase consists of defining the problem. The third phase has to do with the generate ideas and creativity. The fourth phase consists of creating or prototyping a product. And finally, the fifth phase consists of testing the final product. So with all these potential benefits of integrated STEM education, it's important to identify how educators can teach effectively while teachers support issues, teaching practices, teacher effectiveness and materials required to implement an integrated STEM program are vital and should be considered. But why STEM? By 2030, approximately 70% of jobs will require STEAM competencies such as coding, data analytics, computational thinking, and artificial intelligence. In order to keep up with the needs of the future and the even-changing labor market, it's essential to offer appropriate learning opportunities to primary school students to equip them with the necessary skills they needed for the future. And now, about the computational thinking and about the robotics. This is very essential because STEAM education can incorporate the elements and practices such as arts and construction, literacy, grammar, reading, music, and many others, which can be taught to early childhood education, primary education, and further with the use of robotics. And in research projects with simple robotics and programming languages, children aged 4 have shown that they understand fundamental engineering, programming, and robotics content. So how can we integrate robotics or coding into the classroom? In order to integrate coding and robotics into classrooms, teachers should begin by researching fun, well-designed, and affordable kits. For example, first of all, I will show these two robots, B-Bot and Pro-Bot. B-Bot and Pro-Bot is programmable floor robots for young children, which is an easy way to introduce programming in the classroom. Secondly, Lego Mindstorms and Lego Education Kit. Lego Mindstorms in the next level with programmable toys with kids 6 to 9 years old, and young adults will learn the basics of coding languages as they assemble the program robots to dance or play sports with a Scratch-based language. Edison. Edison is a programmable robot designed to be a complete STEM teaching resource for coding and robotics education for students from 4 to 16 years old of age, and it scans unique barcodes to activate preset programs in the robot. Arduino, which is an open source electronic prototyping platform, enables users to create interactive electronic objects. Raspberry Pi is a series of small single-board computers, and it has low cost, this is very important, low cost modularity, and it's open design. And Sphero, which is a programmable robot ball designed to inspire creativity and curiosity through coding and play. Next of this is a Xeno Research Robot. Xeno Research Robot with the 6 basic emotions through play: happiness, surprise, sadness, anger, disgust, and fear, belongs to the category of humanoid robots, such as Robot Now, that contain emotions and contribute to the emotional improvement of children with autism spectrum disorder. Kibo Robot is a humanoid also robot with an expressive cartoonish face. It navigates on its own, understands spoken commands, and likes to give hugs with every one of its 43 degrees of freedom. The creator is Korea Institute of Science and Technology. Ozobot Robot is a smart handled robot that uses sensors to follow lines and read color codes. And Caspar robot, the size of a small child, as you can see, uses mainly facial expression and natural gestures, hand movements, eye contact. All these robots are considered effective for the development and the empowerment of children in areas of difficulty such as speech and socialization. And here in this slide, we have a 10-point checklist for coding robotics integration. For example, how many students can use this kit? Are teacher and student support materials provided? Are the species aids appropriate and durable for repeated use? Are the parts powered by batteries, or does the kit allow for creativity and open-ended challenges? Is this robot programmable? Is the coding software compatible with your device? Here are some tips about integrated robotics in our classroom. First of all, explore. Let the students dive in with the new resources. Encourage students-centered learning. Motivate learners to immerse themselves into the learning environment. Encourage failure. Explain that coding can often need to be tested multiple times, and transferable skills through coding and robotics can encourage other transversal skills, as we said before, in their lives. This includes teamwork, communication skills, critical and creative thinking, and so on. And finally, in order to actively engage learners, it's important to motivate them. When teaching learners about STEAM practices, you can implement strategies to motivate learners. For example, make your class interactive. Consider student-centered learning, inquiry-based learning, and challenge-based learning, as we said before. Add challenges to your teaching sessions. This can encourage active participation, encourage collaboration, implement activities that rely on group work and discussion, include compelling media. A picture is worth 1,000 words. Ensure your learning content is engaging and enjoyable to teach complex theory related to coding and robotics. And finally, encourage feedback. Discover what appeals to learners. This can motivate them with the learning environment. Here is some references, and thank you very much.